I wanted to say some words about data that we collected in the first lab that you can see right here. Essentially, notice that for this first resistor, which was about 1,000 ohms, 980 ohms, the voltages across that resistor, which should be the same as the battery voltage, because there's only one thing in the circuit, and that is the resistor, or two things, the resistor and the battery, so they both have to have the same voltage. Notice for this resistor, the voltage is lower than for either the 470 kilo ohm resistor or for the 10 kilo ohm resistor. And also notice that the 10 kilo ohm resistor is slightly lower than the 470 kilo ohm resistor. This is an important point that may or may not have gone noticed by you. If you noticed it, great. If not, no worries. But it has something to do with the fact that the battery is not ideal. If it were an ideal battery, then the voltage should stay the same no matter what the resistor is for any of the voltage settings. This isn't just true for 15 volts, it was true at 1.5 volts. Notice at 1.5 volts, that 1,000 ohm resistor had the lowest voltage. The 470 kilo ohm resistor was about 1.58 volts. This was about the same. Might have been slightly less, but I couldn't see it in the numbers that were reported. But for all of the other voltages, the voltage that's greatest is the one that has associated with the greatest resistance. And the reason for that is as the resistance gets lower, the current gets bigger. That's passing out of the battery and through the resistor. And as the current gets bigger that's passing out of the battery voltage starts to get lower. In a previous lab, I actually tried to measure the IV characteristics of a battery like we talked about in class. We actually did that in lab. And what we saw in the lab is that when you make the resistance really small, like 2 ohms, 3 ohms, which isn't good for the battery, by the way. The battery gets hot, the resistor gets hot, but the battery voltage drops, which is what I like to see, and the current gets really big, which is not really a good thing, but it's good to see it. That's how batteries respond when they're short-circuited or close to short-circuited. Now, 1,000 ohms is not a short circuit, but it's closer to a short circuit than either of the other two resistances, which are much bigger. Bigger resistance means the battery has to work less hard, and it's able to put forth all of its voltage across that resistor. So I thought that was an interesting way to start the discussion on IV curves. So hopefully this will help you think about the IV curves a little bit more from a real practical standpoint for a battery.